Hey guys, yeah, I'm making this video because I've always had a problem when I'm making lenticulars. I always have a problem when I need to use like synthetic images on either side. Like if you take an image and you get the depth map to generate the synthetic images on the left side and then on the right side. Usually I use Stereo Photo Maker. If you load an image on a depth map and then you go into edit depth map and then create multiple images from a 2D plus depth map, you can generate the what we call tweeners. It's not really tweeners, it's a synthetic image that you would get if you change the viewpoint, going to the left and then going to the right. The problem with the problems I found is that it's always kind of not right. So I had made a video some time ago about this thing, the 3D photo in painting. And basically what it does is that, and I'll give the link to the Python notebook in the description down there. So the input is a 2D image, and what it does is that it creates a depth map using MiDaS, and by default it's also using the Boosting Monocular Depth Estimation, but you can turn it on and off, and I did also a video about that boosting stuff. But anyway, so it creates a depth map. So it creates a depth map, and then it's gonna create a bunch of videos that does inpainting to showcase their stuff, which is inpainting using AI. So I thought about it and I said, oh, why can't I use that to create my my lenticular synthetic images on either side of the input image? I mean, for sure, I'm sure you can do that. If they can do those videos, I'm sure you can do a simple swing on the left and on the right. So anyway, and there's a way to do it. So I'm going to show you how to do it. So I already made a video about how to use this thing, so I'm not going to repeat myself. I'll put the link to the video somewhere, probably now, somewhere on the video, so that you can look at it. But the idea, and here what I'm going to do is that I'm going to use their default image, which is this one, the guy on the moon. So okay, so let me tell you how you do it. So when you run that thing, okay, so this is the stuff. This is the cell that actually creates the point cloud, so the 3D scene, and generates the movies. So what you want to do is to change that one, that argument.yml, and I have it here, and I'm going to show you what to change. So let's see. Okay, so here is you get, what I did is that I put false here so that it was faster to run, but you probably may want to use true if you want to boost the monocular depth estimation. So I put false, which is not the default, just so that it runs faster. That's the only reason. Otherwise you put true. FPS, frames per second. it doesn't really matter, but I put 1 so that when I play the movie I can see what's going on. So FPS 1, number of frames. So I put 6 because I need 12 synthetic views. So this is gonna be 6 for the left side and 6 for the right side. So here what you want to do is for the x shift range, which is basically the shift along the x direction, the amplitude, if you will. So you put minus 0.015 or whatever, some number. You can put minus 0.02 if you want to go further. So you put minus if you want to go to the left, and you put plus or nothing if you want to go to the right. So I'm gonna keep it because here I'm going to the right. The y you put 0. Here I put minus, but doesn't matter. Just put 0. And the z you put 0. Yeah, don't worry about the minus. It doesn't matter. Put minus, plus, doesn't matter. And the trajectory types, you only put straight line. So what's gonna happen is that it's only gonna make one video, and it's gonna be the video, the only video you want. So it has to be a straight line for the type. The video postfix, I put swing, but I mean you can put whatever you want. It's just gonna be the name. So you see, if you put swing, then it's gonna create moon_swing. That's gonna be the name of your video. So I'll leave it as swing. Longer side length, that controls the size of your output. I'll leave it as the default 960, but you can change it if you want something bigger. What else? Okay, this is all default. Image format JPEG. So because this is a JPEG here, that's your input image, moon.jpg. Depth format .png. By default is numpy.npy. So I use .png. I don't know why they use numpy. So I changed that to .png. So require MiDaS, I set true because I want the notebook to compute the depth map using MiDaS. If you have your own depth map, you put false. And when I did the video, I showed how to use your own depth map, so you can go back into that video. Same video. It's in that video that shows how to use the whole thing. So it also shows you how to use your own depth map. This I didn't change, that I didn't change. I don't think I changed anything else. Okay. Okay. So here, plus 0.15, it means I'm going to the right side, to the right. So okay, so what you do is that you change that, and then you go here and you upload it. So upload this one. I already did that, so I don't need to do it. And then what you do is that you just assuming that you've already run the whole thing, you just rerun that one. So this is what it looks like. It's gonna the thing that takes the most time is this one, writing the depth ply, and I think I don't save it. You see, save ply by default is true. Here I say false. I don't think it makes much difference. All it does is it doesn't save the ply file, the point cloud. What else? Okay, so that's what it does. And what happens is that you get this as that's gonna be your output video. So you're only gonna get one. So so I already did all this for the left and the right. So I did this for the negative, so the left, and positive, the right side. So if I go into the negative, I got all my frames here, and I got the video. I saved the video. So this is the video. I'm just gonna run that. And you can see it's moving. So you have 6 frames moving to the left. Okay, and I'll show you the frames. Open with photo viewer. Okay, so this is frame 1, 2, 3, 4, 5, and 6. Okay. Okay. And so this is the on the negative, and you do the same thing on the positive. So when you go, let me go back. So on the negative you put a minus, that's what I call negative, and when I put a plus, it's the positive. So positive, you get similar thing, so you get the video. Okay, so now it's going the other way. Okay, so you get your 6 frames on the other side. Okay, so now it's going the other way. Very simple. So now what I did is that I combine everything into one animated GIF. So open, so that's my animated GIF that I made with GIMP. Okay. So those are my 12 synthetic frames that I can use to make a lenticular. What else I need to say about this? Yeah, how do you extract? How do you extract the frames? What I did is I use AVI demux to extract the frames manually. I'm sure you can do it automatically using VLC or FFmpeg or something like that. But here I'm just trying to see if it works, and it seems to be working. So yeah, so you get the video from the 3D photo inpainting, and you extract all the frames. And in my case, I have 6 frames. Okay. Runtime disconnect. Okay, that's fine. So yeah, so this video is just to show you how to get those synthetic frames that you need when you want to do a lenticular, or if you want to do a wiggle that's straight, that moves along a straight line along the x-axis. So what else I want to say? Yes, so you can definitely use your own depth map. So if you want to use your own depth map, please watch that other video where I explain how to use your own depth map. So I think I'm gonna stop here, and if you have any questions, feel free to put them in the comments. I'll try to answer if I know the answer. One thing I should mention. Oh, this I don't. Okay, close. I don't care. One thing I should mention, and I don't really know how to solve this. Okay, so let me load the input image. So this one is 2100 by 2100. So when you run that, inpainting is reducing to 960, I believe. 960. So let me just scale 960, and for some reason it's 5.8. Okay, so now they are the same. Uh, 25%. Okay, 50%. Let me just put that one at the same view level, zoom level. Okay, so this is the input image, and if you look at the frames, it has been kind of cropped for some reason. That I'm trying to see if you can get rid of that. I don't know if I'm gonna be able to figure it out, but if you figure it out, please let me know, because that would be great if the input image and all the frames that have been generated are kind of are the same zoom wise. That'd be nice. But okay, so that video was just to show you, or even me, because sometimes I don't remember or I got something, how to get synthetic frames if you want to make lenticulars. Alright, that's it. So if you like this kind of content, please like, comment, subscribe, and I'll make more. Alright, bye.